Hi, this is another video of the series of videos Data Science Can Be Faster. And on this video I'm going to show you that probably LAPACK is not the best option to call on Numpy, Scipy, or in Python in general to solve linear algebra routines, linear algebra problems, AX equal B, least squares, problems on eigenvalues and eigenvectors, single value decompositions. So to do this, let me show you a paper of 2014 of Song and Dongarra, a scalable approach to solving dense linear algebra problems on hybrid CPU-GPU systems. And on this work, they affirm LAPACK, Intel MKL, AMD, ACML, and Plasma are mainly designed for shared memory multicore machines. What are these machines? These are machines like this. You have a memory, and all processors use the same memory. So it's probably a machine that you are using right now. Modern multi-core processors are just shared memory systems on a single chip. And we have a joke here. Can't buy a single core processor, even if you wanted one. So they are different from this kind of architecture, distributed memory architectures. Like this way, you have processors that have their own memory, and they are interconnected by some device. So we are here in shared memory architectures, this kind of architecture. Okay, let me show you now that we are going to compare these libraries. And actually on 2017, a group of University of Tennessee and Manchester on Plasma 17 performance report, they already done this test. So let me show you how LAPACK will go against Plasma and also MKL. It's impossible. It's impossible to show you 34 pages in just some minutes. So let me show you, for example, results they got for linear systems to solve AX equal B. We have here a detailed report about these tests for LU implementation of the software, particularly of Plasma, and LDLT implementation. These are factorizations of the matrix, and also implementation about these factorizations mainly. And what do we get results? For example, let us see results for this architecture. It's an Intel architecture, has Haswell, 2 sockets, 20 cores, 2.3 gigahertz, and they perform LU factorization in these 3 softwares, these 3 packages. As you see, for a size matrix of 2000, LAPACK performed 250 gigaflops. Flops, it's floating point operation, and gigaflops, 10 to 9 floating points operations. It's a measure of performance. As high as it is, better. As higher it is, better. So as you see, for different sizes of matrices, LAPACK was always worse than Plasma and MKL. As you see, Plasma and MKL, it's difficult to show you all data right now, but they will be always better than LAPACK. For example, here, they performed well better than LAPACK. We have here the Cholesky factorization in double precision. All this stuff in the same architecture, Haswell, an Intel architecture. Let us see the LDLT factorization double precision. Performance go up as the size of the matrix go up, but LAPACK is in general worse than MKL and Plasma. Same tests in this architecture, also an Intel architecture. As you see, LAPACK is always losing for Plasma and MKL. Here and here, the same factorizations, LU, Cholesky, LDLT. I won't show you all this report, but as you see, you can read this report. I'm going to show you the link, and you can go wherever you want to go. Let me show you what we have here. We have tests for norms, for linear systems, for matrix inversion, and least squares. Oh, something important here. It's not the holy grail. For example, for the best of my knowledge, plasma is not available for ion solvers to find ion values and ion vectors. Single value decompositions is not available to it. But as you see, for linear systems, AX equal B and least squares, plasma and MKL are very interesting ideas. You should consider to use it, to know more about it. I'm gonna do another video explaining it better. Probably 2 videos about plasma and MKL, and how you can use this, how you can use these packages, how you can call these packages from Python and then use them on your problems. Well, we have here also a detailed paper about these experiments. Graphs are the same, and you see particularly stuff about all of these experiments. This is a performance test. Intel, that the company that develops Intel MKL, also have a series of performance here. I can give you the link, and you can see how MKL goes against LAPACK and also plasma. So this is the video about the performance of LAPACK against plasma and MKL, and I hope you find this information value to your operations, to your data science, because if you're performing LAPACK, pure LAPACK, the LAPACK we see here, okay, just a moment. The LAPACK we see here, oops, the LAPACK we see here, you're probably losing performance, you're probably losing time, and probably memory too. MKL and plasma are more efficient softwares. Actually, MKL uses LAPACK routines, optimized LAPACK routines for Intel hardware. So, see you soon in the next videos.